Good afternoon, everyone. How is it going? Good. Welcome to Microsoft Ignite Day 3. My name is Bhanu Prakash, and I am a Senior Program Manager in Azure Databricks team. And with me, I have Abhinav.
Hey, Abhinav Garg here, Lead Solutions Architect from Databricks, working for Microsoft as my primary partner across the East Coast, US and Canada.
Great. So today, we are going to talk about real-time streaming analytics with Azure Databricks on Azure. So in the next 45 minutes, we'll start with the scenarios. What are the different scenarios that we have seen after talking to customers and the scenarios that customers are running in production. Then we'll switch over to how to do real-time analytics with Azure Databricks, and then we'll end up with demo and go through questions towards the end. Now, before I get started, I want to get a show of hands. How many of you are running any workload with Azure Databricks or have heard about Azure Databricks? So maybe 10%. OK. So let's get started. In terms of different scenarios, if we think about real-time analytics, in the past, batch analysis, it started with all batch analysis. So a lot of workloads. You want to make some decisions. You want to do some processing of the data. You would start with batch analysis. But companies and organizations, they want to make decisions in real time or near real time. You don't want to wait for a week for something to happen and then take that decision, right? So if you think about connected car scenarios, a lot of manufacturers for cars and vehicles, what they're doing is they have these sensors on the cars and vehicles. So they get the data in real time from these vehicles. And based on that, they can take decisions like, hey, this part needs to be serviced at this point. And rather, before the outage happens, let the car get serviced. If we talk about ad tech, if you are doing marketing, you want to make sure that whatever ads are put in the digital space that you are in, you want to make sure that those ads, you are getting the return on investment. And if the ads are not making value, if the customer is not making purchases, if there is no CTAs, then you want to make sure that, hey, in real time, I put the ad in a different placement where it is making money, right? If we apply the same scenario to telecom industry, there are a lot of spam messages or fake messages or fraud things happening, and you want to catch that in real time. If you think about banking, you want to make sure that if a fraudulent transaction happens, those are caught in real time rather than when the loss has already happened and then doing analysis of that. If you think about industrial automation, like machineries or wind turbines and oil and energy, these are the industries where they are using heavy equipment and machineries. And you want to make sure that, hey, if something happens, if there is some sort of outage that happens, if you want to do predictive maintenance of these machineries that are used in different manufacturing industries, you want to catch them in real time or near real time. Because if you wait for the disaster to happen, then by that time, it's too late. If you're doing some application development, if you're developing client-side or server-side applications, you want to make sure you have real-time telemetry data that is being collected so that your service or the application that you are running is always up, is performing correctly, and nothing is going wrong. These are just some examples, but it could apply to any industry and any of the use cases. If it is gaming, if it is education, there are some sort of real-time scenarios that you want to combine the real-time ingestion data along with the batch data to make some meaning and make some actions based on that. Now, in this example, E.ON is a customer which has been collecting these real-time sensor data from the wind turbines. And as part of using Azure Databricks for doing analysis for the real-time stream data that is ingested through some streaming ingestion engine, they have been able to reduce the processing time from what it used to take hours to a few minutes. And as a result of that, they are now able to focus on a lot of other innovative applications so that the time that was wasted in processing or the extra time that was incurred in just doing some analysis can be reused in some other meaningful activities. Now, let's take a quick view of the overall end-to-end architecture of real-time analytics on Azure. On the right, what you start with is data that needs to be ingested. And in this case, what we are saying is there is a batch data that is available in different sources and different formats. So you have batch data that will get ingested from your existing on-premises system, whether it's sales data or whether it's some CRM data. And then you have this real-time streaming ingestion data that gets ingested to different sources like Azure SD Insight through Kafka or Azure Event Hub or Azure IoT Hub. And these are managed service to allow you to ingest data from different sources. And you ingest the batch data using Azure Data Factory, again, from different sources that exist. Once the data is ingested, you want to land that data in some data lake. On Azure, that data lake is Azure Storage, Azure Data Lake Store Gen 2, or Azure Data Lake Store Gen 1. Once the data is ingested, you want to do some transformation of the data, analysis of the data, and that's where Azure Databricks comes. Azure Databricks is a first-party, fully managed service to do transformation and analysis, doing some machine learning, graph analysis, et cetera. And once you have done the transformation and done the analysis, then you want to serve the data so that your analyst can consume that data, or your apps can consume that data. And that's where the data gets moved to our operational store like Cosmos DB for the apps to consume that data, or to a SQL data warehouse so that you can connect Power BI to SQL data warehouse and do some visualization and make some key insights using that visualization through Power BI or other visualization tools, right? So now, once we know about the whole end-to-end architecture, let's see how Azure Databricks can help with the analysis, right? So what is Azure Databricks? I know 10% of you raised hand that you already know about Azure Databricks or are using Azure Databricks in production. To those of you who don't know, it's a managed service on Azure to do Spark, to use Spark as an analytics framework for doing analysis. Now, what it means is you could run open source Apache Spark on your on-premises or in an IaaS fashion on cloud. But you have to do that, you have to go through lots of steps of provisioning the VMs, installing Spark, making sure it's the latest runtime, stable runtime. You have to do configuration. With Azure Databricks, you don't have to do all that. It comes as a managed service, and what you have to do is through single click of a UI or through ARM templates or through REST APIs, you can provision these clusters from 2 nodes to 1,000 nodes within a matter of 6 to 7 minutes. So all the time that you would take to get budget for 600 machines or new VMs, all those time just goes away. And as a managed service, we make sure that these clusters get deployed within a matter of few minutes. Secondly, this is based out of open source Apache Spark, but this is Databricks runtime. So we have partnered with Databricks company to provide this as a fully managed service on Azure. So as an end user, it has a lot of benefits that you would not get in open source Apache Spark. And those benefits include, if you look about performance, it is much, 10x or more faster than what you would see in open source Apache Spark. If you look about enterprise-grade security, when it comes to Azure, all the security benefits that Azure provides, let's say service endpoint for storage, or creating this Databricks cluster or workspace in a virtual network, or encryption of the data, encryption in transit, encryption in REST, all the security benefits comes packaged for you, so you don't have to worry about all those things. In terms of user experience, the cluster can auto-scale. So if you are thinking about cost and management, you don't have to create a cluster of fixed size. You can just say, mention in the UI, hey, enable auto-scale, and based on the payload, the cluster can start with a 1 node. And if there are more jobs being submitted to the cluster, it can scale to 1,000 nodes. If you can think about authentication, your InfoSec teams back in your organizations would be thinking like, hey, I don't want to create a new identity provider, or I don't want to have a separate identification mechanism. In this case, the fact that it is very well integrated on the Azure ecosystem, the authentication happens through Azure Active Directory. So you can use your own corporate AD credentials to log in to Azure Databricks and submit jobs by your own corporate domain credentials. So this keeps your InfoSec team happy, as well as you don't have the burden to do things of setting up the Active Directory or new identity provider. And lastly, Azure Databricks is a part of the whole pipeline that we just noticed. It has to read data from storage. It has to move data to a SQL data warehouse. You have to, let's say, if you're using Azure Data Factory, you have to start the transformation of the data or start of the big data pipeline or trigger a notebook activity. So as you noticed in the previous slide, it is multiple activities that comes as a meal to customers. And given the fact that this is very well integrated into the Azure ecosystem, you don't have to worry about creating those connections. So what is Spark, right? Databricks, as I talked about, is a managed service which is basically Spark configuration, or it uses Databricks runtime is basically Spark, which uses the distributed computing. Now, if you think about Spark, Spark itself is not just one use case. You could do machine learning. You could do graph analysis. You could do interactive analysis. You could do deep learning. So all the use cases are available in Spark. And Azure Databricks, since it is basically a framework on top of Spark with a managed experience, you get to use Azure Databricks for all these variety of use cases. And today we are going to talk specifically about structured streaming for near real-time and real-time analytics. Now, if we take a deeper look at the architecture, basically it uses distributed computing framework. So you have the driver node where the jobs are submitted, and then the jobs are then processed by the worker nodes. And depending on how many nodes are there in the cluster, it would take advantage of that based on the payload. And then lastly, what we want is, when you think about the different real-time scenarios, all things starts with, hey, building these real-time applications or doing real-time analytics is hard. And why is it hard? Because there is complex data. The data is available in different sources. The data is available in different formats. Secondly, it's a complex workload. You are not just doing streaming or stream processing. You are also doing machine learning. You are also moving data to a SQL data warehouse. So it's not just a single activity. And lastly, it's not just a single system. While you are using Azure Databricks for doing structured streaming, you still have to ingest data through Event Hub. You still have to move data or visualize data through Power BI. So it's a complex system. And what we want you to take away at the end of this session is how easy it is to do stream analytics for your use case in your organizations in an easy manner without worrying about the underlying infrastructure. So with that, I will give it over to Abhinav to walk through the structured streaming and the capabilities in Azure Databricks and go through a demo.
Hey, thanks, Banu. All of you can hear me? All right, cool. So, Banu has illustrated a few use cases, all cool use cases, and I want to mention that we are working on almost all of those globally. Whether you think about connected cars, whether you think about ad tech, whether you think about predictive maintenance using wind turbines, think of large assembly lines at manufacturing enterprises, right? So we are doing predictive maintenance for those as well using Spark structured streaming on Azure Databricks. So those are all cool use cases. But what is structured streaming? It's a big block of Spark as an open source framework itself. And I work very closely with a couple of engineers who actually wrote a big part of structured streaming in Spark itself. Most of the people work for Databricks. But basically, what it is if you look at this diagram at a very high level, right? Think of structured streaming as executing queries, incremental queries over incremental data, right? So let's say you are running an SQL query over big data or in any SQL Server database from any GUI tool. It's one time you're running a batch query, right? Now think of structured streaming as running those incremental queries over your incremental data sets at particular triggers. So what's happening is that yellow box is just incremental data that's coming at particular trigger intervals. So think of it as an append table. That incremental data is getting appended to that particular input table. That blue box is your incremental query. Think of it as a simple SQL query, right, over that incremental data. That green box is a result of that incremental query. So whenever you are running that incremental query over that incremental data set, that is your incremental result for each batch. And finally, your output update table is how you want the actual result to be updated. Do you want to append all the output results? Do you want to do a complete update every batch? Do you want to do a delta update? So it totally depends on what your scenario is, right? What your end goal is in that case. So structured streaming basically builds upon the existing batch analytics scenarios within Spark. It builds on the Spark core API. It uses the same API from a data frame perspective, from Spark SQL perspective, but basically on the streaming data. So what structured streaming is, it uses the same API. It runs incremental queries on incremental batches of data, batches of streaming data. It's the same API, can be used across Spark SQL core, batch analysis, Spark streaming, and even ML. So machine learning in Spark also use the same API. So you can basically work across different streams of your data pipeline by using the same base API, same base data frame API, right? It provides you exactly once guarantees. So there's proper failover built in. So if your query were to stop midway, while ingesting some events, processing those, it will start from exactly the same point, the next point onwards, right? So that's pretty cool. So there's proper built-in fault tolerance and failover. There is a concept of aggregations and watermarking. What that allows you to do is have sliding windows and tumbling windows over your increment, data that's coming in from a streaming platform like, for example, Event Hubs or Kafka. What that allows you to do is, if you want to, let's say, analyze some sort of sensor events over last 5 minutes only, and you want to say that, OK, I want the latest status for the health of this particular sensor in last 5 minutes. I want to ignore whatever comes after this, or sorry, whatever comes before this. So you can apply a watermark in case of structured streaming. So structured streaming basically allows you to do full aggregations on top of your streaming data, but applying something called watermark. Another cool thing is, because it's built on the top of same API, it allows you to do a join of your streaming data with batch data. You can even do stream joins. So you could have a sensor sending some data via Event Hub or Kafka, some streaming platform. You could have some another customer data that's coming via another platform, probably a customer application, UI application, front-end application. So you could join those together in real time and do data analysis on top of that. So that's structured streaming at a very high level. So some key capabilities, again, from a perspective of structured streaming in Azure Databricks. So what additional does Azure Databricks provides for structured streaming, right? So there are built-in connectors for all of these data services within Azure. So Event Hubs, HDI, Kafka, these are streaming platforms within Azure world, Azure realm. So we provide native connectors for those. We actually can do streaming from your blob storage and ADLS as well. That's pretty cool. So if you have incremental data that's actually coming into a cloud storage, blob storage, ADLS, you can do proper streaming from that as well. We have streaming connectors for SQL Data Warehouse as well. So if you want some analysis to be done, transformation to be done in real time over streaming data, and want to sync that into SQL Data Warehouse, you can actually do that, right? So all of these native connectivities are there. But for some reason, for example, there is some third-party database, not a part of Azure world, but probably as a part of your on-prem infrastructure or part of your IaaS cloud infrastructure, you can actually build arbitrary connectors for those. So there are proper APIs in Spark. Again, we are the Spark people. That's what we call us. So we will provide you full education around how to build those sort of connectors, all right? It provides automatic restart of the queries. Again, as I mentioned earlier, so if you have a query that's ingesting events from some streaming platform, it broke midway, there was some sort of error with the input data, the transformation failed. As soon as you correct it, it will start from the last event only because of something called checkpointing that we have enabled as part of the Spark APIs. Okay? And again, for stateful streaming scenarios, so I talked about a scenario where you're getting sensor data, you want to get the latest update of that sensor health in last 5 minutes. That's really stateful streaming, right? That's stateful analysis. You're not just analyzing each event in isolation. You are basically going back in time, or you're going forward in time, how you see it. So for that stateful streaming scenario, if you have millions of events, and if you want to go beyond what open source Spark offers to you, you have something called RocksDB-based stateful streaming store. So that's, again, what we provide as part of Azure Databricks. Again, I won't go too much into this diagram. Bhanu has already done a good illustration there. But basically, at a very high level, there's an event hub at the start as one of these streaming ingestion platforms that we support in Azure. And that's what we are going to show today as part of the demo. There's Azure Blob Storage. What that basically tells you that, OK, you could do a stream and batch join. And then you have Azure Databricks in the middle, which is basically doing some sort of transformation. You could do real-time scoring with a machine learning model, or some sort of a deep learning model, or you can just do some plain data analysis. And you can then store that data into something like Cosmos DB. So there might be a front-end application which is accessing Cosmos DB, showing the real-time results of a scoring to users, and that's it. It's pretty easy. You basically get all of these PaaS services, glue them together, off you go. And you can also show those results via Power BI. So Power BI now supports streaming data sets as well. So we have proven that out too. So you could very well do interactive streaming analysis within Databricks notebooks or via Power BI. Now, I wanted to talk about something called Azure Databricks Delta, which we basically are releasing as public preview as part of this whole conference. Now, what Databricks Delta is a combination of features, right? It's not just one feature. It's a combination of features that provide you data consistency and even faster. When that says the fast analytics, I say even faster analytics than what even Azure Databricks Spark runtime provides. Okay, so if you have a scenario where your different streaming sources, transforming data, writing to a particular cloud storage, but you have data analysts or scientists who want to read that data at the same time, today you have to implement something called a Lambda architecture. How many of you have heard of Lambda architecture, right? So, pretty good number. Now, the Lambda architecture requires something called, called file compaction problem, right? File compaction is you have many of these streaming events coming in, ingested, being transformed, but these are all single events, right? What it does is it creates small files in your cloud storage. It's pain dealing with those small files because you have to have a file compaction step. You have to compact those files into larger files. You have to let your data analysts and data scientists know, OK, don't query for now. Wait for this file compaction step to be done, and then you can query it, right? So there's a lot of handoff that you have to do between data analysts, data engineering, data scientist teams. Databricks Delta takes care of it automatically, seamlessly, right? Think of it as really as an additional data engineer on your team, right? So it provides you data consistency in terms of schema enforcement over big data on cloud storage at cloud storage scale. It provides you concurrent read and write access over cloud storage, and both in stream and batch sense. And again, it provides you faster analytics, right? It provides you faster querying because it provides you multi-dimensional indexing, auto multi-dimensional indexing on top of cloud storage. So you can create multi-hop data pipelines using Databricks Delta. So you could have stage 1, 2, 3, 4 tables. This might ring a bell when you must have, if you have implemented some sort of a data warehouse, data mart, with the landing, staging, and those different sort of tables. So think of creating that sort of architecture, multi-hop pipelines with Databricks Delta, where you could work with batch data, streaming data all together. And these could be different streaming sources, different batch sources at the same time. All right? So again, different sorts of tables, stage 1, 2, 3, 4, all have their different purposes. So data consistency I talked about. So data consistency basically means it totally depends on if you want automatic schema updates or if you want to actually control that if there's a schema change at my source data, I want to block it right away. So Databricks Delta provides you flexibility there, right? So that's what data consistency is. It also provides you exactly one semantics over that data. Query performance we have talked about. Again, there's something called DBIO caching, where we cache that data locally on local SSDs of Azure VMs. So it provides you, so it basically prevents going back to cloud storage for every query analysis. it fetches that data from the local disk. And it provides auto multidimensional indexing. So there's something called optimize and z-order, which allows you to create those data skipping indexes. So for example, if you're looking for some particular values, we have already indexed those values. We'll just search for particular values in the cloud storage in your files. Sorry. Simplified architecture, we've gone through this. Basically, it provides you concurrent read and write access on top of cloud storage, and with batch, combining both batch and streaming data. There's some administration security tools as well in terms of access control, schema management, and metadata management as well. So there's full table access control that's provided as part of Delta. You can do, you can control what sort of schema updates you want to have. You can actually provide properties that, okay, I want to ignore only deletes, or I want to ignore everything as part of a particular table update. Yeah. This is a typical transaction flow. Sorry. In Databricks Delta. So what you see here in this case is a particular read command below the red line. The first read start basically looks at only one record. But in the green box above the red line, there are two more records coming at the same time. So there's basically read and write happening at the same time. So the first read is only looking at one document. But once the write has been committed for the 3 additional documents, the second read, the purple one, it will look at all those 3 documents. So basically, the readers are looking at their own snapshots of data at the same time. So if I execute a query while a write is going on from a streaming or batch source, I look at my own snapshot. When I execute it again, I look at the most updated data at that point. All right? So that's how we provide concurrent access. All right? And Delta is nothing but Parquet data under the hood. It's not some proprietary format. It's not something that you won't understand. It's not something that your programming language or machines won't understand. It is just Parquet data under the hood. All right? All right, so let's do a demo. OK. So this is the Azure Databricks platform. Now, I'm going to go into a particular notebook, which basically is analyzing sensor events from wind turbines. Now, what are these sensor events? Basically, these are sensor events from gearboxes of wind turbines, which basically allows you to do anomaly detection, whether a particular gearbox is damaged or healthy. All right? So the same example that basically Bhanu explained, even as part of the Eon that they have done. So it's a similar prototype that we have done. So in this case, the first command that we are doing is we are just removing the entire Delta store that we are creating on top of blob storage in cloud. And in this case, if you see, we are just accessing it as a file path. We are not accessing it as a VASP client or a blob storage path. That's the magic in Azure Databricks. You can just mount blob storage or ADLS as a simple file path, and that's how you access it. So this is actually blob storage behind the scenes. So I'm not deleting it right now just for the sake of the time, but basically in this case, we are deleting it. We are creating a Delta raw table using SQL. It's a DDL statement you would recognize. In this case, I'm using the format Delta on the blob storage path for the raw events coming in from the event hub. I'm creating a Delta results table. So basically, I want to apply a machine learning model on all these real-time raw events, store the transform results in another Delta table. Think of it as a stage 2 table. Then I do some necessary imports for structured streaming. I provide the connection parameters for my event hub. It requires a namespace name, event hub names, SAS key name, and the actual SAS key. If you have passwords, keys, secrets, etc., you do not need to provide those in the notebooks directly. You can actually use something called our secret API. Okay? And you can use Azure Key Vault as well as a backend. I provide a configuration for that event hub. I specify the schema for my events. Now, these are all different parameters for those sensors that I'm getting. And this is a reading type, what it actually had calculated as, whether it was damaged or healthy. And in this case, I'm I'm basically creating a data frame, a streaming data frame for that configuration. I'm applying some transformation on top of it. Because this is all JSON data coming in, I want to parse that JSON into actual field values. And what I can run is, I can do a simple display. So if you want to do interactive query analysis on streaming data, you can do that as part of an Azure Databricks notebook itself. So in this case, it is actually reading that data now in a streaming manner from Event Hub, and it is running Spark jobs incrementally on that incremental data. So what it will do now, it will actually display that data. So you see, so now this data can be refreshed. And if you want to convert it into a visualization, you can very well do that very easily just by the click of this button. All right? I can start writing this data to a Delta 1 raw table that I just created earlier above. So in this case, what will happen is my trigger will execute every 5 seconds, and it will start fetching 1,000 records every 5 seconds, because that was the part of my configuration earlier. And it will start writing it to this raw table path that I created earlier. And I have the checkpoint. Checkpoint is basically allows me that fault tolerance, built-in fault tolerance exactly once guarantees. I can now stream directly from this Delta table. That's pretty cool. So I can do proper CDC from this raw Delta table. I can read my machine learning model, apply transformation in real time, doing real-time scoring on that data, and I can start, so once that is done, I can start writing those transformed results into the stage 2 table at the same time. So basically, this is now executing as a data pipeline. And you do not have to worry about any file compaction here. In a typical Lambda architecture, you'll have, basically, this will have to be broken into 2 or 3 different pipelines or sub-pipelines. This is pretty easy. Like in 3 or 4 boxes, you're running a full data pipeline across 2 Delta tables. And I can stream out of that Delta table as well, the third one, and I can display some results out of it, like how many records are being updated as damaged or healthy, for example. You can do any sort of analysis display on top of it. You can access those tables via proper SQL in the notebook. You can run Scala, Python, SQL, or R. You can do describe detail on top of that table, basically see how many files have been updated, what's their overall size. And it provides you provenance information as well, like what all updates, what all processes are being happening on those tables, right? So it provides you that lineage as information as well. Finally, just before I wrap up this demo, basically there's a machine learning model that I'm using here, which has been pre-trained, which is transforming those events. This is the notebook that I used to create that random forest model, basically, on the wind turbines data. And internally, let me just come to that particular portion. So this is where I'm creating my training and test data sets. I'm using PySpark ML. I'm using random forest classifier. I'm using cross-validation to basically do hyperparameter tuning. I'm picking up my best model, and I'm saving my best model to blob storage. And this is the same model I'm using in my streaming notebook as well. All right? Yep, so that's what I wanted to wrap up with. Q&A? Oh, okay.
So thanks, Abhinav. Towards the end, I do want to call out about the newer announcements that we are doing for Azure Databricks as part of Microsoft Ignite. So one of the things that you noticed in Abhinav's demo was when he was connecting to Azure Event Hub as an instance for data source or Azure Blob Storage, you did not have to provide the keys, the actual keys in the notebook. Because Azure Databricks is a collaborative environment, we expect that, hey, there is a team of data scientists or team of data engineers who will work in a collaborative manner on the same notebook. And when there are multiple people working on the same notebook, you don't want to provide the access keys that will give access to the whole kingdom of storage or the different data sources. So with Azure Key Vault, which is the secret management store on Azure, you can put those keys in Azure Key Vault, and you can just refer those keys in your notebook so that the different multiple data scientists will no longer have access to those keys. Secondly, Azure Databricks trial. So we launched a trial version of Azure Databricks, which provides 14 days free DBUs, and you don't have to pay for the DBUs. Of course, you have to pay for the VMs, but the DBUs are free for the first 14 days. We are expanding today. We are on 24 regions in Azure, and we have added 4 more regions in the last 1 month, which is Japan, Canada, India, and Australia. Abhinav talked about Azure Databricks Delta. It was running in private preview for quite a while, and we are excited to share that right now at this conference we are announcing the public preview. So it helps, as you noticed, it helps with data consistency. It helps with building a robust data engineering pipeline, and you can also do real-time streaming analytics along with batch in the same unified model using the same set of APIs. We have also introduced Azure AD conditional access. So as you noticed in the first few slide decks, we talked about the authentication for Azure Databricks happens through Azure Active Directory. Now that is great. A lot of enterprises who are using other applications on Microsoft like Office 365 or any other Azure application, there is also this conditional access capability that comes with Azure Active Directory. And what that means is for your InfoSec team, they want even finer level of access control, not just Active Directory authentication. What they mean is like access to this Databricks cluster to do data processing should happen only from a specific set of network locations or should happen from a specific set of devices. And all those fine level access controls for authentication, you can do it through conditional access, which is generally available. Now, oftentimes we have heard this feedback from our customers when an Azure Databricks workspace is deployed, it gets deployed in a managed VNet. And the reason it gets deployed in a managed virtual network is because we want it to be secure. We want your workspace to have the perimeter level security. But at the same time, some organizations want some flexibility in terms of how they control the traffic, how they want to establish user-defined routing, how they want to securely connect to other Azure services like Azure Storage, Azure Data Lake Store with service endpoint enabled. And all those flexibilities can now be possible today with the gated public preview of deploying Azure Databricks Workspace in your own existing or a new virtual network that you have full control on, but at the same time ensuring that the required network security group rules are also there to ensure the cluster is up and running. And finally, I would like to end that as part of the streaming, what we have also enabled a powerful capability is as part of your entire ETL pipeline, while you can push the batch data that is being analyzed from Azure Databricks to a SQL data warehouse, we have added streaming functionality into that. So imagine a scenario where Abhinav was talking about this Event Hub demo, where there is real-time data being coming in. On the fly, while the data is being transformed in real-time manner, you can use the SQL data warehouse connector so that that stream data being transformed in real time will be available in your data warehouse so that your analyst can consume that data in a real-time manner and make insights. So with that, I will pause here. We have 7 minutes, and we are open to Q&As. I hope you enjoyed.
Sure, yeah, like that's fine.
The question is, how is this different from HD Insight?
That's a very broad question, but HD Insight is another managed service that's provided by Azure. Now, HD Insight uses open source Spark at a very high level. Databricks is optimized runtime of Spark. Databricks is the company which has all its co-founders which created Spark, and we still contribute 75 to 80% of this Apache open source Spark open source code base.
Yeah, and the other way to look at it is like HD Insight is a lot of open source components. You get Kafka for real-time streaming ingestion. You get Hadoop if you're using Hadoop, or if you're using Hive, or if you're using Storm and those OSS components, then that is the way to look at HD Insight. But if you're looking specifically for Spark because all of the benefit that it provides, then Azure Databricks is the way to go.
Does it replace Stream Analytics?
No, it does not replace Stream Analytics. So Stream Analytics is for example, if you have edge devices on edge IoT devices somewhere, and if you want to run, for example, analytics on the edge. Stream Analytics is definitely the platform for that. If you want to do some rule-based analysis without going into data frame APIs of Spark, you could very well use Stream Analytics for that as well. But if you have millions of records that you want to get via a streaming platform, and then you want to combine it with some bash data on blob storage, on a RDBMS, or on some sort of a NoSQL database like Cosmos DB, then Azure Databricks is your platform. Stream Analytics won't provide you those capabilities.
Gotcha. And you did not demo how to connect that to Power BI, right? Does Databricks throttle itself so it doesn't flood Power BI?
So Power BI connects to Databricks via JDBC ODBC connector. So that's the main route. That's the pull route. Basically, pull data from using the Metastore tables. But you could use Power BI's own streaming dataset functionality to send data from Databricks to Power BI.
Right. So my code will be in Databricks sending to Power BI. And about the throttling, I'm responsible for the throttling?
And the way to look, if you look at the whole big picture, the way we recommend is like, yes, you can use Power BI and through Databricks directly and do the visualization. But if you're looking at a very high scale with lots of users in real time, then you could move the data to SQL data warehouse or some sort of relational store, and there connect Power BI to SQL data warehouse and then visualize the data that can withhold all.
But that will be pull, yeah.
Yeah, but with that, I lose the real time or near real time.
Yes, that will pull. That will incremental pull. That will be, yeah.
Right. Thanks.
Yep. Sure.
I'm super excited to see Databricks in its own VNet. Particularly, thank you on behalf of my InfoSec team. But I have a double-click question here, just to make sure I can use it. Sure. Does that mean that all the services that today have a VNet endpoints would be able to connect directly through those endpoints?
Yeah, so that does mean like services, Azure Storage, Azure SQL, AKV, or whatever newer services in the future support service endpoint, you will be able to support service endpoint with this VNet engine, being your own VNet feature. Yeah.
And then additional question, and I don't know the details about Databricks because I wasn't allowed to use it, but I would imagine when there's a Spark job, there's worker nodes being spawned for that particular job. Are all of those Spark workers actually provisioned in the background in that very VNet so that my security team is happy?
So basically the NICs are in that VNet.
Yes.
Yeah.
Fantastic. Thank you very much.
Sure. Any other questions?
So we do have the related sessions in this slide. If you want to learn more about Azure Databricks, these are some of the related sessions that you want to take a look at.
All right, thanks everyone.
Thank you.